8th graders, it's Mrs. Thompson. We are going to jump right into our next strategy for solving quadratic equations. We've been working super hard on learning how to graph to find those zeros, to factor, if it's factorable, to find those zeros, to use the square root property. And now our fourth strategy, and we have 5 strategies. This is our fourth one called completing the square. Now, I want to draw your attention up here to the strategies. And we talked about it, graphing, that works if the zeros are integers. And I think sometimes it's effective. We've been using our calculators. We've tried the trace button. We've used the table. We've looked at the graph. Sometimes you just can't tell enough details to get the exact answer from the graph. So that's why I said that graphing is sometimes effective. Factoring, if it's factorable, then factoring is effective. But as we've talked about time and time again, not all quadratics are factorable. So sometimes that's an effective way of finding your answer. The square root property, sometimes you can use that if there's no bx term there. Then you can use it. But if there is a bx term, you can't use the square root property. So let me tell you what is a strategy we can always use. And that is completing the square. I'm going to show you another strategy when we hit 8, 9 that you can always use as well. So I'm going to give you some choices. And so you may attach yourself to one strategy versus another, but I want to show you both of them. And today we're going to learn how to complete the square. In example 1, I want to show you the process. I want to teach you the process for finding that number that will help us complete the square. Now, let me kind of give you a little background information. You are on purpose, deliberately trying to create a perfect square trinomial. Now, look at example 1, and I'm here at letter A, and I'm going to show you how to make this soon-to-be trinomial a perfect square trinomial. First thing, make sure they're in descending order, in standard form, that your square variable is first, then your bx term, and this is the number right here, your constant number. That's the number that we're going to mathematically calculate and put there, okay? Here's the process. It's really simple. Take b, which is positive 10, divide it by 2, and then square that number. Okay, so we can do this in our head. What's 10 divided by 2? 5. And what's 5 squared? 25. You just made this trinomial a perfect square trinomial. This thing is factorable. We could factor it right this second. Okay, let's look at letter B. Okay, we're going to do the same process. First, make sure we're in descending order. There's your x squared, there's your bx number, your term there. Now we're looking to what constant number we're going to add here. So you're going to take the b, which is negative 9. You're going to divide it in half, and then you're going to square it. Now, I don't normally work with decimals. I wouldn't change it to a decimal right this second. You can, but I think that might actually be a little bit more confusing. And so what I would do is leave it as negative 9 over 2, and then what you're going to do is you're literally going to square the numerator, which is negative 9. What's negative 9? That integer squared. You're right, that's 81. And then square the denominator. 2 squared is 4. And so that is the number we're going to add. That 81/4 makes letter B a perfect square trinomial. Okay, even though it doesn't look like it, it is now because of the 81/4. Okay, let's look at C. Make sure it's in descending order, that we have ax squared first, then bx, and now we're going to figure out the C. So go here, positive 12, divide that by 2, and then square that number. So we can do this in our head. What's 12 divided by 2? 6. 6 squared, 36. You just made that a perfect square trinomial. Okay? So I've got a couple of other ones here. I'll do one more odd one with you with letter D because I want to make sure you know how to do those odd ones and how to handle them. Try not to turn them into decimals, please. Leave them in their fraction form. It'll make more sense when we get to example 2 if you just please trust me in this regard, okay? So it's in descending order. There it is, ax squared plus bx. We're going to take b, which is -5. We're going to divide it by 2. Now, because it's an odd number, I'm actually not going to divide it. I'm going to leave it there and just square what I see. Square the numerator, square the denominator, and that number, 25/4, is going to make that a perfect squared trinomial. Okay? So I've given you process. First step, make sure it's in descending order. That's going to really affect you in letter E. I'm going to make that extra credit, okay? And then take B, put it over 2. If it's an even number, go ahead and divide it, and then square that quotient, okay? You think you know what to do? So bring your questions to class about this particular example if you have any. Hopefully it was really simple for you. Okay, we'll talk to you tomorrow.